Hey friends, we're just going to talk a little bit about now our symbolic logic unit. We're starting out. And we've already talked about conditional statements, and we're going to talk about them specifically symbolically today. But we're also going to get a few more new symbols and terms and truth tables based on it. And the first thing we're going to get is what's a proposition. A proposition is just a statement that is true or false, which means it's either going to have a false or true validity. For an example of that would be something like, today is Monday. And right now, as I'm recording this, it is Monday, so that would be true. But if I said this on Tuesday, it would be false. So, knowing that, we could still prove that as a true or false statement. Not a proposition. I just want to give you a quick example of that would be something like, let's sing. It's like a command. I'm not being able to do truth or false. It's just me telling you to do something. That's not a valid statement. Now, we've been using propositions already. We used them with conditional statements. The hypothesis and conclusion were both propositions, so we just didn't use that term. Notation is a capital or lowercase letter. So you can have Q, Q, R, and so on. So we can choose these. Now we use them already with conditional statements. We had hypothesis and conclusions. What is a conditional statement? Just remember, it's an if-then statement. And the symbol we used for that was the arrow going to the right. Remember, this is the one. I'm going to highlight it. It's going to be a little bit brighter colored there. But, I want it to be that arrow, if then. And we let P and Q, P be our hypothesis and Q be our conclusion. An example of this would be if you are in Geometry Advanced, we're just going to abbreviate here, then you will learn symbolic logic. And the thing is, we even developed a truth table for this, so we can make sure our propositions, like here we have our hypothesis, you're in Geometry Advanced, that's a true or false thing that you can figure out. You will learn symbolic logic. You will definitely learn that if you're in my class. So here we had our first proposition, which is our hypothesis, our second proposition, which was our conclusion, and we did all truth values for these, and we did our truth table. And remember, we used the truth table of picking a guy in the class and seeing if he promised his girlfriend if he was going to take her to the movies or not. And we realized there was only one time that a conditional statement's ever false, is if you have a true hypothesis and a false conclusion. So I want to make sure that I know this one really well, and the rest of the time you just have to memorize it. They're going to be true. So not too difficult there. But now we actually have more types of symbols than just a conditional statement, just our arrow. We're now also going to have a conjunction. I know a lot of you are going to junction, function, No, I think it's conjunction, junction, and you had it in the Schoolhouse Rock. Well, conjunction, remember, stands for the word and. It means we combine two propositions together. We make a statement. The symbol for that is like the capital letter A, but without the bar. Some of you could think of it kind of like the union symbol that we use for set notation in math as well. An example of this would be something as Joe is 2 years old and his birthday is in May. Now, we ask this boy, Joe, is he 2 years old? If he says yes, true or false, and we have his birthday's in May, so true or false. Now, the reason why I brought up the union symbol, or this in case our and symbol, it's using the idea that of a union or and, that they're glued together and cannot separate. So once you're married, like two become one. And so when I do my validity statements, I cannot get rid of my false statements. Now notice I start the same. My two columns stay the same when I work with it, so I can get all possible combinations. And when I read these, I go true and true, or true and false, the validity. So true and true, obviously I'm going to have a true statement. But if I have a true and false statement, the false now actually wins out over the truth one, because I can't get rid of the bad from the good, so it's going to be false. Then I have a false and true, which is false. Then I also have a false and false statement. Well, a false and false statement is completely false. So there's only one time that a conjunction, an and statement, is ever true. And that's when you have both truths, when we work with it. An example of this would be Mrs. G teaches geometry. And let's think of this, teaches Bible. All right, now, the thing is, we know it's true that I teach geometry, and we use our symbol, do I teach Bible? Well, no, I'm not a Bible teacher here now. I teach my kids the Bible at home, but not quite the same thing. So that's a true and, excuse me, make sure I make the right letter there, false statement. So true and false makes it false, exactly. So that's a validity of the thing, and we're going to learn to do that symbolically. Then we have our disjunction, which stands for the word or. And the symbol we use for that is a capital V. Okay? So that V is like the opposite of it. Now, when I say opposite, think or as either or. They're separate. So something like to this. Today is Monday, or today is Tuesday. Now, here's the thing. I'm actually at this very moment, okay, working with this here for a moment, please. I am working here on a Monday, so I know that's true. And I have or, and then I have today is Tuesday, which is false. But I have a true or false statement. I can always pick the true this time because I can pick either or. So as a person who likes to say honesty, we're always going to pick the true one. All right, now we're going to flip the page over and we're going to go from there.